Okay, the law of cosines, it's a little bit more challenging just algebraically than the law of sines in moving things around. I just want to show you that on my site, what I have is I have the triangle drawn and little a, little b, little c like before. I give you three equations which are in fact the exact same equation. It's just based on which angle or side you're looking at. So if we're involving angle A and we're looking for A, anything with A, then I'm going to have this equation. If I'm looking for B, everything will be almost the same except it'll change to B squared is equal to, well, instead of B, this will be A squared plus C squared minus 2 instead of B, AC times the cos of B. And again, the third formula I have is now this will be C squared is equal, and you can change it again. You'll see what happens. It'll be exactly the same. The one thing you should know how to do with this formula is sometimes we're going to solve for a side, and sometimes we're going to solve for an angle. Okay, I'm going to show you that if I take this equation right here and solve for cos of A, what it'll look like. And I'm going to do that right over here and just say, well, moving this around, okay, I'm going to subtract B squared and C squared. So in other words, I'm going to get A squared minus B squared minus C squared. Right now, that's going to equal negative 2BC times the cos of A. Okay, so that's what I get if I move this around. I still want to solve for cos of A, and so now I'm going to divide by negative 2BC. I'm going to divide because that's multiplication right there. And so what I'm going to get is I'm going to get A squared minus B squared minus C squared, all divided by negative 2BC, and that's going to equal cos of A. And again, the last thing I'm going to do here is to solve for angle A, I have to take the inverse cos of this. So I'm going to do that down here and just say that the measure of angle A will equal the inverse cos of this whole mess, okay, of A squared minus B squared minus C squared all over negative 2BC. So if I'm ever solving for the angle, that's what I'm going to have to use when I move this around. I'm going to show you that because of these two examples here. The first one being this one, I'm looking for a side. So because I'm looking for a side, I can use the straight up equation, no angle here. And again, this is little b, actually, that will be x. Little c is 11, and little a is 9, and angle b is 30 degrees. To solve for this triangle, what I'm going to get is I'm going to get here that I'll call it b squared is equal to, I'm going to use this equation, a squared plus c squared minus 2ac times the cos of angle B. Okay, it's because we're looking for that one. That's why I'm using this notation here. When I do this one here, well, I'm going to plug in all my numbers, and I'm going to get 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of apparently 30. So now I have to punch this all in my calculator. And just remember, this isn't solving for B, it's solving for B squared. Okay, so you'll have to square root it at the end. I'll just punch this in really quick. 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 30. And let's see what that gets me. When I do that, I end up getting B squared is equal to, it's around 30.52. Again, I'm going to just square root that answer. And I get around, B is equal to around 5.5 roughly. It's around 5.5. So this angle here is going to be around 5.5. You can almost guess that this angle is going to be larger. You could solve for this angle now using sine law, because now we know the opposites. And so we could just jump into sine law here very quickly. I'm going to go on to the last example here, which involves solving for an angle. And suppose this time we're looking for angle A. I'm going to call it x. Okay, we're looking for angle A. We know that B is equal to 12, C is equal to 16, and little a is equal to 14. Okay, so we're going to look for angle A. And again, I've solved for it before, but we had this equation here. So I'm going to use this one again as we've solved for it. And you end up getting the measure of angle A is equal to the inverse cos of A squared minus B squared minus C squared all over negative 2BC. You can punch in your numbers beforehand instead of solving for this. But now plugging this in, I'm going to get that that's the inverse cos of, well, A squared is going to be 14 squared minus, let's see here, B squared, which is 12 squared, minus 16 squared all over negative 2 times 12 times 16. Okay, and I'm finding the inverse cos of that. Again, be careful how you punch this stuff all in. I'm going to say 14 squared minus 12 squared minus 16 squared. I get some number. It's a negative. That's fine because I can already see the negative is going to cancel here. I'm going to divide that by, I'm going to put in brackets, negative 2 times 12 times 16. And when I do that, I end up getting 0.53125, so some decimal. Again, I'm going to leave that on my calculator and just say I want second function cos, because I'm finding the inverse cos of that answer, so of the answer. And when I do that, I end up getting around 57.9. So I get around 57.9 degrees. Okay, that would be this one. And that's my answer there for that. Just to refresh your memory between the differences of cosine and sine law, you can only use sine law when you know an opposite pairing. Right now we could use it because we have this opposite pairing. If I don't have that, I have to resort to the law of cosine because I'm missing one ratio, and so I couldn't solve for it then.